an up counter, however many bits it is, I'll use a 3-bit counter. An up counter just counts up 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and then back to 0, 0, 0. That's an up counter. You can imagine what a down counter does. So you start at 1, 1, 1, and then you go to 1, 1, 0, and then 1, 0, 1, and then 1, 0, 0, and then 0, 1, 1, and then 0, 1, 0, 0, 0, 1, 0, 0, 0, and then back to 1, 1, 1. So that's an up counter, and that's a down counter. So they do exactly what you would think. But now let's talk about a Johnson counter and a ring counter, because they're a little bit different. So a Johnson counter, let's do a ring counter first. So a ring counter, I included on here what the schematic is. So this is the actual circuit. I don't have another one. So these are mine.
Oh,
Yeah.
I'm so sorry.
Sorry, yeah, I only printed 2 because it was like 1,000,000 pages. But if you want one, I can print one and we can go get it out of my office. Okay. It is on Moodle.
Yeah.
Okay. Yeah, and so if you want this reference, that's on Moodle. So okay. So this is how you would make it if you needed to make the circuit. The clock pulse is applied to all the flip-flops simultaneously. That's what makes it synchronous. But we are going to be more concerned with what the output is. And so we can see that what happens is that each time you have one of the bits is 1 and the others are 0. And so the ring counter moves along like that. So the way the count works is you would have, depending on what direction it's counting, this one is counting in the, I don't know if it tells us what direction, well, we don't have a ring counter. So 0, 0, 1 is the way I would start, 0, 0, 1, and then 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0. But it depends on which of these is Q1, and it might be the opposite order. So that's the way a ring counter works. So, and let's do that. So a ring counter. But another way to think about it, so that way it makes sense when you have just a single bit that is hot. That's called one-hot encoding. But you can also have more than one bit as 1. So, and it can still be a ring counter. So I could have 1, 1, 0, 0, and I'm going to just double check and make sure that I'm telling you right on this, because this website did not have this information, and I didn't think to double check before I just cut and pasted and believed that it would. So in your book, page 270 has an up counter, 271 has a down counter with T flip-flops, okay, and then also with D flip-flops, And then it says with load, and we talked about what a load was earlier. Other types of counters, so a ring counter. So this one is saying, yeah, so this one is saying exactly what, so it is saying exactly what the website said, so it is not any different. Oh, yeah. Okay. So I was thinking that you wouldn't necessarily have to have just 1 for the ring counter, but it looks like it's saying that it does. And if you look at this text from your book right here, and again, I'm showing you this because sometimes it shows up on the test, so don't, even though it's not on your homework, it's definitely worth knowing. So the ring counter, this one is showing, that's a 4-bit ring counter. So just, the 1 just moves along like that. Okay, so what does a Johnson counter do? So a Johnson counter is similar, except a Johnson counter takes the last bit and takes the knot of it and brings it around to the first bit and shifts everything to the right. So what it does is it's going to take, these 3 bits are going to stay the same, but they're going to be shifted to the right. So I'll have 1, 0, 1, and then I take the complement of this, so the opposite of 0 is 1, and I put it in front of these. Okay, then the next count, these 3 stay the same, 1, 1, 0, but they're shifted to the right. I take the knot of this one and move it to the front. So why don't y'all write what you think the next one is going to be, and then see if you get the same. Why don't you just keep writing until you get back to the start and see if we end up with the same count. So I'm going to write it up here too, and you can see if you end up with the same thing that I end up with. So I got it on the 1, 2, 3, 4, 5, 6, 7, 8th turn. I hope that wasn't the one that y'all had for homework. No. If it was, don't tell me. Okay, so the one that I had on my worksheet was oh, I apparently have 2 number 5s. So I think the one that I have is the same directions as your homework, just with different numbers. This one says to start with 0, 1, 0, 1. Yeah. So with the 0, 1, 0, 1, if another way to do the ring counter is just to bring that final bit back around up front without swapping it. And so this one with a ring counter, if it was just a single 1, that single 1 would move along. But if I have more than 1, 1, if there's a 1 at the end, it comes around to the front but does not change. And so this one, it repeats after just 2. For a ring counter. This is a ring counter. a Johnson counter on this one. The next one would be 0, 0, 1, 0, because the 0, 1, 0 stays the same. The one at the end comes around to the front and becomes a 0. And then 0, 0, 1, 1. And then 0, 1, 0, 0. And then 1, 0, 1, 0. And then 1, 1, 0, 1. And then 0, 1, 1, 0. Did I make a mistake somewhere? 1, 0, 1, 1. 0, 1, 0, 1. 0, 0, 1, 0. Did I make? I feel like I'm repeating. That's two. Okay. 1, 0, 0, 1. 0, 1, 0, 0. 1, 0, 1, 0. Finally. Was that where I was trying to get to?
Yeah.
Oh. What?
No, 0, 1, 0, 1.
Oh, so I got to that
Yeah,
right
yeah.
here. I got to that earlier. Okay. And then in up counter, I would start with 0, 1, 0, 1, and then I just count. So that's 5, 6, 7,
Okay.
8, 9, 10, 11, 12, 13, 14, 15, 0, 1, 2, 3, 4, 5. And so an up counter, it's always going to take, you'll always repeat back on the 16th time because you have to go through all 16 numbers. Yes?
So, wait, I'm confused on the ring. Like, what method do you do?
Okay, so it's really the same method. It's just traditionally you just have a single one. And that we say it looks like that single one is just traveling down.
Okay.
But you can think of it also the same as these three are moving to the right and this one is coming around up front. Because that's the same thing that's happening. So if I had 1, 0, 0, 0, these three shift and the 0 that was at the end comes to the front. And then these three shift and the 0 that was at the end comes to the front. And so how does that translate if I had more than one 1? So these three shift to the right and the bit that was at the end comes up to the front. So it's different from a Johnson because it's not being complemented.
Okay.
Yeah,
Okay.
that's the difference.
Gotcha.
That makes a lot of sense.
Yeah.
Yep. And then a down counter just counts backwards. Any more questions before I stop this? On counters before we do the next thing?